Okay, so for problem 8, we're either supposed to decide if something is an observational study or an experiment, and depending on what we decide, we have several different questions to answer. So problem 8 says the leg muscles of men aged 60 to 75 were 50% to 80% stronger after they participated in a 16-week high-intensity resistance training program twice a week. So is this an experiment or an observational study? And the answer to this is that it's an experiment, okay? Because everybody who participated, we forced them, we imposed a treatment. And that treatment was participation in the resistance training program. So they weren't just we're not just passively sitting back and seeing activity and saying that people who go running or whatever exercise have stronger legs, but we're actually forcing people to participate in this resistance training program. Okay, so here now that we've decided it's an experiment, now we have to identify the subjects. So the subjects here were the patients, or the men, not the patients, I'm sorry, the men who participated. And in this case, they were all 60 to 75 years old. C says the factor in the experiment and the number of levels for each. Okay, so in this case we only have one factor, and that is whether they participated in the training program or not. And actually we only have one level because we didn't have anyone who didn't participate in the program. So it's one factor and one level, and that factor is training program and that level is they participated. So it seems a little weird, but that's what we have. Okay, so we don't really have a control. Okay, we just have one factor and everyone's at the same level. They're all just participating here. Okay, so the number of treatments here is there's only one treatment. Only one treatment, and there's no control group. Just everybody participated together. And the response variable measure was, I'm going to write RV for response variable, and that is the change in strength, okay? So it's not explicitly stated in the problem, but we have to assume that if they said they were 50 to 80% stronger, we must have had a strength test before the program and a strength test after. And so there was a change in strength. And that's what we're measuring. Oops. And now we're letter F. So the design is completely randomized, blocked, or matched. Okay, we barely talked about design, but this is a matched design because we're comparing one man's strength to his own strength. We're looking at a particular man's strength after the program versus his strength before the program. We're not just comparing two different men at two different times, but we're comparing one man to his own strength from before. So that means it's matched. Same subjects. Okay, was it blind or double blind? Probably not blind, okay? Because I think most of these guys would have known if they're participating in the strength program or not. Okay, it's possible to have blinded people who make the evaluations, and so people who are measuring the strength, they might not have known if they're measuring the strength before someone participated in the program or after he participated in the program. They might ask, just measure this guy's leg strength. And then in that case, there would be blinding in the person making the evaluations. But the participants cannot be blinded. All right, in the nature and scope, so any results or conclusions we draw to can only be applied to other, 60 to 75-year-old men who participate in the program. So we can't just generalize this and say this is going to work for younger men, or it's going to work for women, or even men of a completely different age group. But we can only say, with confidence that our results probably will have a similar effect to other 60 to 75-year-old men who participate in this training program. But beyond that, we really can't say a whole lot.